The average rate of change of a function f of x over the closed interval a to b is the slope of the line segment between a f of a and b f of b. What that means is that we have some function, f of x, which in this picture is drawn in blue, the function f of x. And we're looking at a certain part of that function, or a certain interval of that function. So we're looking at the function between a and b. So those are our x values, a and b. And what the average rate of change is the slope of the line segment that connects those 2 points. So you can see the blue curve f of x is not a line, it's a curve. But the average rate of change is going to be that line segment that here is in red. The slope of that line segment. So we want the slope of this line. Okay. And to find slope in high school math, you probably learned the slope formula, which is the slope, which is m, usually represented as m, equals the change in y divided by the change in x, or y2 minus y1 over x2 minus x1. Except in this example, we're thinking about function notation, so instead of y2 minus y1, maybe we would think of f of x2 minus f of x1 instead of y2 minus y1. So we're calculating the slope of the line that connects those two endpoints on whatever interval we're looking at. So let's look at an example. Example 1, find the average rate of change of f of x equals x squared over the interval 1 to 4. So what that means is our two x values that we're looking at, or the interval we're looking at, is a equals 1 to a equals 4. So our average rate of change is going to be f of x2 minus f of x1, or f of b minus f of a, which means that we're just going to plug in our endpoint 4, our second endpoint, minus f of 1, our first endpoint. Because our function here is f of x equals x squared, that would be 4 squared minus 1 squared, which is 16 minus 1. So we're subtracting those two function output values, which is 15. And then the other thing that we do for average rate of change is we need to do x2 minus x1, which is just going to be subtracting these two x values that are the endpoints. So subtracting b minus a, which is 4 minus 1, which gives us 3. And then at the end here we then have 15 over 3, which simplifies to 5. So what that means is that this number 5 is like our m, our slope of that secant line between a and b for the function f of x.